Okay, so I've been avoiding one section in the book, but I'm just going to tackle it. The idea is when you have a curve along the y-axis, and the example the book gives, um, they ask you, the aim is area along the y-axis, and they give you this graph. It looks something like this. And it's the function y equals 2 radical x minus 1. And they want you to find the area. They want you to find this area here. In here. And so it's a little different. It's a little different than what we're used to. So, first thing is first. The idea is that what we're used to is that we're seeing y as a function of x. And so the idea is that we start at x values. So for example, let's start at 10. We start at 10, we go up to the function, and that tells us what the y value is going to be. And in this case, 10 minus 1 is 9. The square root is 3 times 2. So, y of f of 10, that's equal to 6. Now, there's absolutely no reason why we can't transform this function and get so that we have y values that will take us to the x values. So we can transform this equation so that x is a function of y. Simply put, we get a bunch of y values, and that takes us to x values. We get a y value, and it takes us to an x value. And so the idea is that, so how do we do that? Well, you simply, we have y equals 2 radical x minus 1, y over 2 equals radical x minus 1, y squared over 4 equals x minus 1, and x is equal to y squared divided by 4 plus 1. What you might say, Mr. Adler, that looks like a parabola. Well, the fact is, this is a parabola. But it's like it's on its side. We're not studying these because you can see that this parabola is continued. It's not a function. This course really depends on functions, but we can still transform it. Now, why do we need to do this? Because if you think about let's take a look at this now. We're still interested in this region. Let me get a different color. We're interested in this region. And what you might have noticed is that, as I said before, it's all about the rectangles. And you say, oh, wait a minute, there's rectangles in here. The rectangles. The rectangles go, so the idea is we can find the area of the curve. It's still the sum of the rectangles. It's still the area is still the sum of the rectangles. Right? But in this case, first of all, let's look at this one. It's obviously the function minus 0. So we still have right minus left. And the question is, where do the rectangles start? Where do they end? Well, they start down at this y1, or 0, and they go up to this y2. What we found was 6, and that's the idea. So it's y1 to y2, and now it's dy. Dy. That's the idea. Sorry, it's really sloppy. So how do we find the purple area? Well, once again, we know we're starting at 0. The rectangles start at 0 and they go up to 6. And our function, our rectangles, the height, well, let's not talk about the height of the rectangles. Let's talk about the length of the rectangles. Let's imagine this is a broken ruler. Or, yeah, we start from the right and we subtract the left. So we're starting at the function, which is y squared over 4 plus 1, and we're subtracting the x-axis. And then dy, and then you can figure this out on your own. I believe the answer is, what is the answer? The answer is 24. And once again, let me write that, and that's basically it. That's basically it. So if you once again, if you have a function, either it's along the y-axis or the rectangles are moving up and down, transform everything into functions of y, find the lower limit, and then move up to the last rectangle. That's basically it. There's really not going to be that many problems, but and we don't have the math yet to do some of the stuff. So, for example, one of the questions is, here's the sine wave, right? Here's y equals the sine of x, and then they give us the cosine wave. This is y equals cosine of x, and you're asked to find this area in here. You're asked to find the area in here. Now, there's a couple of ways of doing this. You could either chop, so you say, well, you know, what's on top, what's on bottom? You know, what you might, what method one might be, to break this up into 2 parts. And so, you know that this is the upper, over here, that's the sine wave. But over here, the upper is the cosine wave. So you might have to break it up into 2 parts. A more advanced way might be to say, you know what, I recognize that cosine is always, we have the rectangles. Cosine is always to the left, the right, and sine is always to the right. And so you might say, you know what, I'm going to find the integral from 0 to some y1 of the inverse of cosine minus the inverse of sine of x. We don't have this yet, so you're going to have to wait. But it is a problem in the book, and I'd like you to think about it. So complete, I think it's 17I. You can do 17, and you do the rest of 17 now.